their workmate go down very nobly, and it's usually a gut reaction. I'm going to go and I'm going to save Ken because I saw Ken go down in that space. I had no idea why. Next thing you know, I go down in that space myself, and then Ken gets rescued and I die, or we both die, or maybe we both get rescued. But the point is, some people think, well, I'm going to hold my breath, I'm going to run in there and grab them and run out of there. It just doesn't work that way. And sometimes it only takes 1 or 2 breaths of a toxic atmosphere to knock you out. I will admit this, back in my younger days when that show Survivor was on, I think it was one of the first seasons where this guy captured a pig, like a wild boar, and they were all starving. I guess they were eating rice for weeks on weeks. So they got to cook this wild boar up over a fire. The guy who caught it wanted to smell it, right? This roasting meat. So he leaned over the fire and took a really deep breath. And between the lack of oxygen, all the smokes and particulate matter, he passed out and he fell into the fire. His literal hand got melted. He ran into the ocean because he woke up once he hit the fire, and they evacuated him from the island, and he did not win. So there's other chemicals that can literally, knock you out with a couple breaths. A good one is a hydrogen sulfide, swamp gas. This is something that you can encounter a lot of times in confined space entry, depending upon what kind of soil or decomposing material you got around and how the vault or the confined space is set up, et cetera. So we really can't rely on holding our breath. We really want to find a way to do something better to protect yourself. So why do we need a respirator in the first place? Somebody throw out some answers. Why would you want to put one on? Because they're a pain in the butt to wear. Any ideas?
Filter out harmful particles.
Yep.
Fumes.
Protect your lungs.
Yep, protect your lungs, particles. So you're talking about different types of respiratory hazards, right? So what kind of groups of respiratory hazards do we have? Somebody already said particles. So particles are aerosols.
Vapors.
And
What's
vapor
that?
and gases.
Yep, vapors and gases, right? Good, those are different things. Good. What else?
Fumes.
Yeah, fumes. Fumes are different than vapors and gases. We typically get fumes from welding, right? And any kind of high heat work that's done on metals. So there's a few things that we're concerned about, right? Aerosols, dusts, mists, and really dust, mists, fumes, and radiological materials are all aerosols. So an aerosol is a particle that's in a fluid medium. And the fluid medium that we're concerned about here is air. So your air is fluid, it's moving around, and anything that is a particle nature or has a presence like that, not a vapor or a gas, but a particle. So it could be a water droplet, an acid droplet, something like that. That's an aerosol. The bioaerosols that contain COVID-19, those are aerosols. We're concerned about those. The other thing I have on here, though, is low oxygen, right? So this also is a respiratory hazard as well, because without oxygen, we're not going to make it very far. And then depending upon the levels of these things, it might be okay for us to be exposed to some of this, right? The levels might be too high or too low in some cases, like with oxygen, or they might be so high we have immediately dangerous to life and health conditions. And these are very particular issues because the respirator that you choose has to work in IDLH conditions. It's very important. Most of the air purifying respirators, PAPRs, those things are not going to do it. So we have to look at some type of supplied air respirator with an escape method, depending upon what you select. Safeguards must also be used when you enter these conditions. You've got to have an attendant that's in constant communication. The employer's got to have an emergency rescue plan, retrieval equipment, appropriate PPE. If you're going to be doing anything like this, what you really have to do, because there's a standard, a law for it, is you've got to, follow the confined space standard, and you've got to make sure that workers are trained under that as well as the appropriate training under the respiratory protection standard for making those kind of entries. Now, I'd imagine IUPAT members probably do, you know, painting on the insides of vaults, tanks, confined spaces that you can get in, right? So it's important to keep an eye out for that. And also, you know, there's an issue where something that you're doing, right? Maybe applying some coatings to a wall or something in a normal environment is not going to create IDLH conditions, but the same use of that material in a confined space will, right? So you got to be really, really careful about where you're working. So is there a standard for respirators? Yes, there is. In general industry, it's 29 CFR 1910.134. The construction standard is 1926-103. It's the same exact thing, and it just defers to the general industry standard. For those folks in Canada, we've got the CSA Z94.4. That's the most updated one. And thanks for Simon Hazelwood for helping direct me to that. Respiratory regulation may be contaminant specific as well. So you might be dealing with a very toxic substance like asbestos or benzene, silica, and it actually has specific requirements for respirators in there. So selecting the right respirator is not as easy as folks think. That's why it's really important for workers to have a general understanding of the basics of this stuff so they can make sure that they're getting what they should be. It's a requirement under the law that the employer does the right thing, but just in case, right? We want to give as much knowledge as we can to workers. With that said, we're going to do activity 1. So that is called Understanding the OSHA Respiratory Protection Standard. I have on here 30 minutes. Ideally, this would be if we are face-to-face, but we're going to try to do this in about 15 minutes or so work time, and then we'll try to debrief it in 5 minutes. So no more than 20 minutes, we want to be moving on. So one of the things that you're going to use to help with this activity is the 1934 standard that you've got. And I apologize to those folks in Canada. I didn't think of this, but I will get a copy of the Canadian Respiratory Protection Standard to make sure that is uploaded and available for the next time we teach this class. So with that said, Alice is going to throw you into some breakout rooms. We're going to set the timer for 15 minutes, and we'll check in and out with the breakout rooms. So there are 10 questions. So you want to try to split this up amongst yourselves to make sure that we can get all these answered. Okay, folks? All right, Alice, take it away.
Okay, all right, so I have you broken up into 6 groups of about 5 people. I think group 3 has 1 less. And I do have it automatically set to close the room after 15 minutes. So once 15 minutes is up, it will return you back to the main gallery. So I'm gonna open all the rooms now. And if you guys can each take a few seconds when you get in there, you're all from different district councils. Just do a quick intro among the 5 of you so that you know who you're talking to. Okay, here we go. Ronald, you should see something on your screen that asks you to join the breakout room.
Question, how does the standard define a building?
Ronald. There you go.
Oh, hey, Alice.
Yes, you should, if you want, I think you should be able to join any of the groups as a co-host.
Okay. Yeah, I'll hang out here, give them a little time to get into this.
Okay.
So how did we do with attendance? Did everybody
We're missing just one person.
Okay. Is that good?
Well, you know, we're missing one.
Yeah, right.
But no, that's not bad. I'm sure Nicole will reach out to figure out what happened to him.
Just a side note, I think that the intro thing went well.
Okay, good. Except I had since I'm not using my video, I had my laptop on the floor and Nicole said you couldn't hear me very well. So I saw there's a feature to automatically end the room after the time you want. So I set it for 15 minutes.
Okay, perfect. Yeah, we'll see how we're doing on time, and we might need to like just set the last activity for you know, less amount of time.
Right.
Ken's 2 videos, I think, will be 20 minutes total.
Okay.
And I can always, you know, just skip one of those, depending too. So
Right.
yeah, I get an air conditioner for this room. It's heating up.
Oh my gosh.
Yeah, our house was built in '76, so we have like window units and stuff, and I never put one in the office, but it's south facing, so right now it's cooking up.
Yeah.
Let's see. So let's see. Let me try joining a breakout room. So I can join one and then leave.
Yeah. So you see the breakout rooms at the bottom or somewhere on your screen
The bottom.
or wherever your menu bar is.
Breakout rooms. Yep.
Yeah. And then you should be, as a co-host, you should be able to click on any of those rooms and join. There should be a join word next to each of those rooms.
It just says if I click on breakout rooms, it gives me only number 3 to join.
Well, let me,
Says you have been assigned to breakout room 3.
I mean, I can reassign you. You want to start at 1 and I can just move you. You have to come back each time and I can just move you.
No, that's okay. I mean, I think if they're all trainers, that's good. I'm confident that they'll be able to get through these questions without a problem.
Okay. Yeah, I only put you in 3 because that's the one they were missing somebody in.
Figure the less interference from me, the faster they'll probably go.
Yeah, they might ask you questions.
What's our clock look like, Alice?
I'm trying to see how I can find that. A breakout room in progress. 9. We're going on 10 minutes, so
Okay.
5 more minutes.
I'm going to step out real quick.
Okay. Yep. 5 minutes. So actually, the clock is counting down, so we have 8 minutes to go. I thought that was a
Oh.
quick first 10.
This will be a good gauge too. We'll see how long it actually took, folks. I mean, if it seems like everybody got through well, this might be the good amount of time. Maybe we can even shave some minutes off, or hopefully we don't have to add any.
Right, yeah. Actually, I'll send everybody a message to let them know. If they're finished, I'll give them another, at the 5-minute mark, I'll say, if you're finished, you can come back to the main session.
Perfect.
That'll be our guide.
Perfect.
But I'll do,
Yeah,
I'll
then-
do that when we hit the 5-minute mark.
Nice. How are you doing, Alice? Almost
Good.
up?
We have about 3.5 minutes.
Oh, phew.
Seems like a long 15, doesn't it?
It does. I've stared at my phone. I've stared at my pen.
I know. Well, I broadcasted a message saying when you're finished if you finish early, to join back to the group. So I guess we'll gauge and see if they even had a chance to finish all the questions.
Yeah, so I mean, the other option too is next time, for doing it online, I can cut the questions in half,
Yeah.
fan them out. They're all good questions, so I'd hate to lose them, but maybe if we can split them up.
Right. Yeah, because that would mean each person would get 2 questions. All right, they're coming back. All right, we're under 2 minutes now.
Okay.
All right, about 30 seconds.
Okay. It's only just after 2:30. It's not too bad.
Mm-hmm. Yeah. All right, time's up, so they should be coming back.
Okay.
30 seconds to leave their room, and then they'll be back. All right, it looks like everyone is back, Bernie.
Okay. All right, folks, what I'm going to do is go through it. I'm just going to, go through the questions one by one. You don't necessarily have to read all the text. I just want to make sure that, you got an understanding of where to find the information, what the information was. And so for number 1, how does the standard define a filtering face piece? What does it mean? Where'd you find it?
It's in the definitions.
Yep, good. It's in the definitions. means negative pressure particulate respirator, ... right? And I have this one, I put this one in there because again, there's a lot of confusion over N95s. You know, is that a respirator? You know, you've seen those, I don't know, I just call them dust masks, the ones that are only one strap that's, you know, it's not an N95 material. A lot of confusion over what those are, so. Okay, good. Number 2, list the provisions of a written respiratory protection program. What section of the standard did you find that in, and what are a couple of them?
Section C 1 through 4.
Good, yep. So it's 134 section C1, and then there's a bunch of provisions under there, you know, including a written respiratory protection program, medical evaluations, selection, things like that. Good.
What?
Go ahead.
I was just going to say site specific.
Yep. Number 3, listed designated respirators for use in IDLH atmospheres. It's actually 2 spots that mentions this.
SAR and SCBAs.
Yep, yep, and you can find those in 134D, number 2, or 134 paragraph G, number 3. Good. Number 4, what is the assigned protection factor for a full face APR?
50.
50, yep. That's in 134D3IA. There's a table there that lists all the APFs. This process determines a worker's ability to wear a respirator and must be conducted before a respirator is donned.
Medical evaluation.
Yes. And it's very important that the medical evaluation is done before a fit test, because somebody could put that respirator on, not know they have a heart condition or something, you know, have labored breathing for a couple minutes, and next thing you know, they're under cardiac arrest. So very important provision. Number 6, list the required times a fit test must be conducted. There's a few items in here. Where'd you find that?
1910.134 F 1 through 4.
Yep, good. Prior to initial use, different respirators selected to use, at least annually, and if there's any, you know, physical changes, jawline changes, surgery, weight loss or weight gain, could affect the fit of the respirator.
Repeat that standard again.
Number 7, what paragraph of the standard lists requirements for respirator face piece seal protection? What are the 2 requirements under the paragraph?
The 1910-134 G1 and 2.
Yep, so G1, a couple options are clean shaven, right? Nothing can interfere between the face and the face piece seal. Nothing can interfere with the valve function if you've got a valve. You know, that could be tampered with. And then there's a user seal check has to be done each time. All right, good. Number 8, which paragraph of the standard lists requirements for cleaning of respirators?
134H.
Yep, good. What is the grade of compressed breathing air required under the standard?
E.
Grade
What was
D.
that? Yep, grade D, good. That's found in I1, lowercase I2. State the part of the standard where you can find information about voluntary respirator use.
Appendix D.
Appendix D, yep. This is kind of a trick question because I didn't give you the appendices, just the meat of the standard, so. Good, any comments or questions on that activity? Seeing none, I shall move on. All right, good. So this is, again, really important. One of the first things that I usually do if I go in to do an audit or an inspection of a work site or workplace is I ask for paperwork. It's the exact same thing that an OSHA field inspection officer is going to do. So if it's respirators, I want to ask for the Respiratory Protection Program. They have to have one. It's got to be in writing. So basically, you know, any program that's written, it's designed as the employer's recipe or direction manual for meeting the requirements of a standard, whether it's respiratories, confined space, fall protection. So it's very important that it is in writing. It is the law. Other parts of the respirator program has to attend to selection, medical evaluations, fit testing, procedures for routine and emergency use, and then inspection, cleaning, maintenance, and storing. And again, all this is written down. Ensuring adequate air quality and quantity and flow, training, administered and maintained by a qualified person. So, an industrial hygienist, a safety professional, someone that's might have taken some respirator courses from like an OSHA Ed Center or something like that, or a union training center, but they've got to be qualified to understand the standard and understand the aspects of how to administer that program in their work environment. And then there's got to be program evaluation done annually, and then any time that there is found a deficiency in the program. This is things that OSHA will look for when they updated the standard in 1999, which is now a very long time ago. One of the things that they did is they created a guidance, a fact sheet for employers to let them know what they're going to be looking for if they go out and look for respirator deficiencies. So they're going to ask workers some questions. And some of them are why a respirator is necessary and how improper fit, usage, and maintenance can make it ineffective, limitations and capabilities of their respirators, effective use in emergencies, and then how to inspect it, don and doff it, where to store it, etc. So if they go up and, OSHA asks, a painter on a construction site, some of these questions, and they're not well answered, the field officer is going to have an idea that the employer might not have done what they should have done for that worker concerning a respirator. If you can answer these things right off the top of your head without a problem, it means that they've probably got a good program in place and that the employer has given them appropriate training. Other things to look at is maintenance and storage, medical signs and symptoms that may limit or prevent the effective use of a respirator, and general requirements of that standard that we just all went through. So first and foremost, before you hand out a respirator for somebody, you've got to go through the hierarchy of controls. In fact, the language right out of the standard is respirators are to be used for protection only when engineering controls have been shown to be infeasible for the control of the hazard or during the interim period when engineering controls are being installed. So it might be a quick fix, but an employer just can't throw a respirator out there and say, hey, put this on, that's going to protect you. They've got to go through an evaluation process of those hazards on the site and determine if they can be controlled by engineering controls. And if they can, they have to implement them. And, or I should say feasible engineering controls. And if they can, they've got to implement them. And while that's happening, then they can ask workers to wear a respirator. But there might be a case where you've got engineering controls working and you still need a backup respiratory protection program. An example, I just did some work for a laboratory that did blood lead analysis, and they were using an agent, a reagent called Dropkin's reagent, which is cyanide based. And right in the safety data sheet, it said, use with ventilation and an air purifying respirator as backup. And if you cannot use it under ventilation, you must use a supplied air respirator. So there was a case where even if they had ventilation working, they still wanted to see at least an air purifying respirator as backup. It's best to eliminate or engineer out the hazard, before. So we've got a couple examples here, filters on a paint booth, a wet saw for cutting concrete. And here's this actually comes out of one of your training centers here up in New Hampshire. It's a nice DeWalt rotary hammer that's got, it's got a vacuum device here to actually capture the dust, and it works pretty good. I tried it out. So if you can do any of this stuff first, do it. It's not just the requirement of the standard, but it's just better because we all have worn respirators. They're not fun. So what is a respirator? What do you think this thing is? How would you describe it to somebody?
A breathing apparatus.
A breathing apparatus, okay. How else could you describe it? So if your kids came up to you and said, hey, what does this do?
Protection from harmful
particulate.
dust particles.
Yep.
if worn correctly?
Yeah, if worn correctly. So basically, it's a device that's either going to protect you against something hazardous in the environment, right? So it's either going to filter it out, or it's going to adsorb or absorb it out. We'll get into that later. Or it's going to provide you an actual atmosphere to breathe. So it's going to give you an oxygen supply, and you won't have to worry about what is in the air. And somebody said if worn correctly. So yeah, we'll get into that. And that's a very important comment and thing to understand. So what are the two classes of respirators? We've got two general classes.
Air purifying and supplied.
Yes, air purifying and supplied air. Very good. So this is part of the class where if we were all together, I would pass out a couple of buckets of these things and you'd hand them around. But close your eyes for a brief moment and imagine that. All right, we'll see that there are many types of respirators that you can select. They've got different requirements for inspecting, fit testing, et cetera. And from what I've seen from most of the photos of your training centers and discussions that I've had with some of your trainers and DOTs, you carry all kinds of respirators. It runs the gambit at your centers, and workers use all of them at some point. So atmosphere supplying, so it's going to provide clean grade D air, and you're either going to have an air line, right, where you've got this long air hose that's going to be able to provide air to your face piece, or you're going to have it all right with you, either on your back or on your hip in some form of self-contained breathing apparatus. Not the same thing as you'd use in diving. Can't take this with you underwater. There's a difference in pressure for both classes of respirators. So you've got negative pressure and positive pressure. So what are these things and what do they mean for the person wearing a respirator? So what is negative and positive pressure, and how are these things beneficial to a worker? What do you think? What does negative pressure mean in the respirator?
That you're doing the work.
Yeah, you're doing the work. So as you,
coming in.
yeah, there's air coming in. So as you're sucking air in, you're trying to get it in through the filters, right? And if you've got a leak anywhere around the face field, air is going to come in there because it's under negative pressure. So what does positive pressure mean then?
More air pushing out.
Yep. So you've got air pushing out, and we can have this provided by either supplied air or the powered air purifying respirator devices that I'm sure most of you have seen. Which one of these is better for a worker to protect themselves against respiratory hazards? Is it better to have a negative pressure respirator or a positive one?
Negative?
Positive.
Positive.
Positive, yes.
Positive.
Why?
Air going out.
Yep, that's right, positive, because if you got a crack in that seal, air is going to be forcing out of there, and you're not going to have to worry about contamination sneaking in to your breathing zone. Good. There's two types of regulators. There's a pressure demand and a demand. I don't believe that demand is even manufactured anymore. I know you're not allowed to use demand under the regulation for IDLH conditions. So pressure demand means that anytime the regulator senses a pressure differential, it's going to push air into the face piece. Demand is basically a negative type of regulator where every time you breathe in, it's going to click on, give you air. But if you're not breathing in, there's no air forced into your face piece. So technically, it's either stable or negative pressure. Obviously, the pressure demand one, always giving air, regardless of what you do, is going to be more beneficial to more likely increase the chances of contaminants staying outside of that face piece. Here's our air line, right? So we've got this, face piece design, and hooked into it is going to be a line that's going to go back to a series of air supplying either tanks or a generating source of some type. So the airline, you can have this in continuous flow, which is nice. So you're always getting a supply of air into the face piece. So if you're using something that's loose fitting, this is nice because, for instance, you don't need to worry about having, you know, the same kind of medical issues as wearing a loose fitting hood because you're getting a constant supply. It's not a tight fitting face piece. People who have been claustrophobic sometimes can get away with wearing something that's loose fitting as opposed to a tight fitting face piece. So it certainly offers some benefits. Can you use something like this in an IDLH environment? So a loose fitting hood or face piece?
No.
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 Nope. Good. Must be tight fitting only with an escape SCBA. Would you classify continuous flow as positive or negative pressure?
Positive.
Good. How come?
It's constantly coming in and pushing out.
Exactly. It's always pushing stuff in. Air quality for an airline has to be grade D, so you can get this through like a cascade tank system or some type of compressor. So, you know, there's some issues, obviously, if you're using compressors. You got to locate it in a spot that's going to give you access to clean air. You don't want to be put it, you know, around idling vehicles, things like that. The air's got to be filtered. You've got to watch out for, you know, anything that might be producing contaminants, whether it be car engines or anything else, welding, you know, things like that. Are there any issues with these construction compressors? Could you
They
use
have to
one of
be
these?
filtered.
What's that?
They would have to be filtered.
Yeah, good, good. Using something like this, you got to make sure that it's got a filter, you know, an alarm system on it. So here's some examples, you know, moisture traps, dust filter, hydrocarbon absorbent. So, you know, it's scrubbing incomplete combustion material out of the air, a carbon monoxide alarm or high alarm temperature for oil compressors. So you got to make sure that this stuff is all there, and not that, you got to make sure it's maintained, right? So if you're using these kinds of systems, that's got to be recorded in that respiratory protection program, and the maintenance schedule for your breathing air system has to be addressed as well in that program. How about limitations of the airline respirator? What do you think they are, if there's any?
Got friction.
Air running out?
You can only, yeah, your air could run out, but usually we can continuously supply a good amount of air to that wearer for a long time, but it could run out. What else?
Mobility? Maybe mobility because of the line?
Yeah, right, yep.
The line could be damaged.
Yeah, that's right. Good. Yeah, so you got to enter and exit by your same path, right? So what happens if there was an emergency and you couldn't go back out the same way? The air hose can be tangled or damaged. You've got a 300-foot limit according to the standard. And there's issues with IDLH atmospheres. You'd have to have an escape bottle. I don't know if anyone's ever done any coding work like on submarines or ships, but they're a tangle of compartments. You know, I had a good friend who did welding work on the Seawolves down here in Groton, Connecticut. And he said it looked like a tangled mess. It looked like, what he used to call it, spaghetti. A bowl of spaghetti, everybody working in the Seawolves, you know, doing their work. Everybody had an airline respirator, and it was just a mess. So there are some issues. Now we get to SCBAs. So you bring the air with you. So there's two types of circuits. There's an open, which allows exhaled air to pass to the atmosphere outside the face piece. This could give some issues, you know, if you're wearing like a level A suit, right, where you got a valve on the suit somewhere, so your suit's going to fill up with air at some point because you're dumping air into it. You've got to burp the suit to get that air out. Then there's also closed or recirculated air. So this air is scrubbed, carbon dioxide is removed, oxygens are concentrated, and it puts it back into your face piece. These are great, you know, for certain firefighting, hazmat operations. I've not seen them used much. However, they're very expensive. And this is a photo of one of the newest ones out there. So what are some of the benefits of an SCBA? What would you think?
Mobility.
Yep, you can go wherever you want. What else?
No compressor.
No compressor, right? And that's one of the factors why it gives it the highest protection factor. So it's got a protection factor of 10,000.
So then you probably wouldn't need the carbon monoxide alarm on that, probably, right? With the
Nope, that's right. What kind of alarm do you have though?
Low pressure.
Yeah, low pressure alarm. So what are some of the limitations? So we got low pressure alarm.
The amount of time you can spend working.
Yep. Yep. And if it's a 30-minute rated bottle, do you have 30 minutes to work?
No.
no.
No. Hopefully you don't have a 10-minute walk to get to where your work is. What else?
Just the physical demands of what you're wearing on the worker.
Right. Yep. Yeah, depending upon what kind of rig you've got, they're heavy, and they're cumbersome.
You're walking around with a tank of oxygen on your back too. So I'm sure flames and anything like that, welding, anything around you, not a good deal.
Yep. Yeah. So remember, it's not pure oxygen though, but it is compressed air, right? So that is an issue. I remember I was giving some emergency response training to a research laboratory, and they had to set up their own ER team. So we were doing a drill in level B, and they walked into one of their labs, which was god messy. I mean, they had glassware everywhere. You could barely walk through, just as you are. And they went in to try to evaluate the scenario. One of them turned around and their tank swiped all the glassware off of a desk. I didn't even see it coming. I would have never thought it would have happened, but I learned a lesson, as did they, that you have to make sure you can fit in spaces with an SCBA. Probably some of you have seen that toluene tank explosion that happened. It was recorded back in the early 90s. It was a toluene tank, and somebody was going to be lowered down through the hatchway up above. It was like 18 inches diameter. They couldn't go in with their SCBA tank, so they were lowered down first. Then the folks at the top lowered their SCBA tank down to them. Obviously, they passed out and did not get it. So the fire department was called in, and they started to cut through the outside of the tank with a saw. And they hit a flammable range, and it was a pretty significant explosion. I think 3 firefighters died, and a number were injured. It was such a heavy explosion, they had thoracic displacement. So the organs of their throat area basically were displaced from the blast. That's how they died. And the entrant was dead. They found out that the entrant died before the fire department ever got there. So there's issues with, can you fit into the spot that you're trying to get to? It does require a lot of training to use one of these. They're very high maintenance. And as you already said, the tank adds bulk and weight. Any comments or questions about air supplying respirators? All right, let's get into air purifying respirators. This is the one that most people have probably put on and used. So what types of APRs are there? So air purifying respirator is short for APR. What kinds do we have?
Half mask.
Yeah, got a half mask.
Full face.
Full face, yep. Couple other ones.
Air assisted.
Air assisted, yep. So that power purifying respirator. And we got one more.
Quarter mask.
Yeah, the quarter mask. I don't even know if I've ever seen one of those in my career. The other one is the filtering face piece, the one that's been in high demand, right, for the last 4 months. And then under the APR, you've got different types, right? You got a tight-fitting elastomeric face piece or hoods, helmets. All right, so here's these folks, right? These are what's in hot demand right now. A negative pressure particle respirator with a filter, and it's part of its face piece. So the whole thing itself is the actual filter. Some of these might look different. You might have a ported valve. There's been some discussion that, the ported valves, if you're sick, you're going to be spreading contamination. I have no studies that show that that's true. A number of my colleagues actually have some studies that show that that's not true. It's not going to increase your development of risk to occupants who aren't wearing one if you were sick. But anyway, There's a couple of different kinds. The port does make it a little bit easier to use and to breathe. Should these even be considered respiratory protection? It depends. It depends what your work is. I would like to see any medical provider in one of these hot, outbreak situations not even have one of these. They should all wear elastomeric half-face respirators. They have some uses depending upon what your hazard evaluation shows, but they're cheap, right? They're cheap and they're easy to put on, and that's why folks usually get one of these from their employer. Here's a half-face elastomeric respirator. So here we've got a nice upgrade in protection. You can see the two valves on the right and left here, right? That's going to be where your air intakes are, your cartridges screw into, and here's your escalation valve. Here's an example from NIOSH of a couple different parts of the respirator. And all these things you're going to want to make sure that you're inspecting and maintaining in accordance with the manufacturer. And we'll get into that a little bit later. Now we've got an upgrade to a full-face air purifying respirator. So why would you say this one would be better? Is it better than your half-face? I see people nodding their heads yes. Why is this one better?
You can definitely keep stuff out of your eyes.
Yeah, right. It gives you eye protection. That's a big deal. What
It
else?
has a higher protective factor.
Higher protection factor. That's right. So this is a 50. Why is this higher protection factor? What's the reasoning? What do you think?
Better seal.
Yeah, better seal. So instead of having to deal with all of our different noses and stuff, the shape of our faces is a little better to fit when you have something like this. Now we got power air purifying respirators. There's a bunch out there. I've got a welding rig down there on the bottom. You can see we got a loose fitting hood and a couple of elastomeric tight fitting face pieces there. Does one cartridge fit all of your contaminants?
No.
No, they're color coded and they do not fit all the contaminants. You've got to make sure you've got the right cartridge for the right contaminant. It's not going to protect you. A chemical cartridge doesn't filter out dust. A dust one does not take out gases and vapors. You can get a combination one, right? That can do both. Here's the color code, right? Depending upon what you're looking at. Black is a good old organic vapor, which is what is used many times because a lot of our chemicals are organic based. High efficiency particulate air, that's our HEPA filter. They call it magenta. I've never heard of the color of magenta in my life, and I did take a couple art classes in college as electives, but nonetheless, it's called magenta. I will call it purple, but anyway. All right, so gases and vapors, okay? So we're gonna look at what this does first. These things are gonna either absorb or adsorb to the filter media. So absorption is the thing that we've got here on our left. So the chemical is taken up into the physical structure of the capturing substance or the filter. So an absorbent chemical is going to be absorbed by the filter and involves that process. Adsorption is different. Here the chemical is attracted to the surface of the capturing substance or the filter. So an adsorbate, the chemical, is going to be involved with the adsorbent, tongue twisters, in the process. So here we got a little description visually of what this looks like. So an absorption, it's actually going to get sucked into the material. Think of a sponge taking up water, okay? As opposed to a sanding block, when you've got like sanding material that's just going to cover the surface. I heard some folks talking, so there's some questions or comments. What can we do? Any comments or questions? No? Okay. So again, there are different materials, right? So the absorption, an adsorbent is going to actually suck the material, the chemical into it. Adsorption, it's just going to suck it onto its surface. So they're two different things. And this is what you're going to find in those chemical cartridges. An aerosol filter works differently. So here we've got 4 different methods that an aerosol filter are going to use to capture particles. So the top thing, we've got inertial impaction. So here, what you've got there, that red line, or that line that's drawn around that big yellow dot, that yellow dot's our fiber. So the red line is the air. So the air is going to float around that fiber piece. And here our black circle, that black dot's our particulate. It's just too heavy and too big to flow with the air. So it smashes into the fiber. How did I do that? Interception's a little different. So now we've got smaller particles, and they're going to be able to float with that air jet, that air stream. But they happen to get just close enough to that fiber, and it clings to it. Then we've got real tiny things. So we got really small particulates, and they are going to float around the air, and that's what our little zigzag thing is here. They're going to float around the air like a gas or a vapor. So they're going to actually mimic it. And what that's going to do is it's going to just randomly fly around, and it's going to go in and out of that air stream, and it's going to hit the fiber and get captured that way. And finally, we've got electrostatic attraction. So here we've got a negatively charged particle, and that's going to adhere to a positively charged fiber. One of the reasons why, not one of, the reason why you've got a shelf life for HEPA filters, your N95s or your N97s, or the true HEPAs, the N100s, is because they're electrostatically charged, and over time that is going to diminish. Now you also can have some structural decay as well of those, but really what we're looking at is the electrostatic charge gets diminished when it's just sitting there on a shelf. As you're wearing it, the filter might get used up by being clogged, so the spaces in between the fibers, but also the electrostatic charge is getting used up as well. So that's how a filter captures those things. So we often talk about efficiency, right? We've used the phrase efficiency a lot for N95s and 100s. So a HEPA filter, or filter efficiency, is always tested with a 0.3 micron diameter aerosol. The reason why is they just happen to, by the laws of nature, be the best at slipping through these filters. Things that are smaller are going to diffuse onto that filter, and they're going to be captured by electrostatic precipitation. So let me go back here. So the real small things are going to be captured here, right? The larger particles are going to be captured by impaction or interception. And then right in the middle here, between those sizes, we're going to have diffusion and interception work. But for whatever reason, 0.3 microns just seems to be the sweet spot that can slip by at the most. So that's why they use that 0.3 size to determine how efficient respirators are. Things that are smaller and larger than that are going to be captured with better efficiency if they're aerosols. Okay, really important to understand. So the particulate filters are size dependent. They're not going to protect you against gases, vapors, and they're not going to give oxygen. NIOSH classifies them into 9 different classes, and we're going to get into this. There's 3 levels of efficiency, and then there's 3 resistances for oil resistant, oil proof, or not resistant at all, so NR and P. And then we've got different designations for efficiency: 95% efficient, 99, and then what's called the 100. But it's not actually 100% efficient because there's no such thing. It's actually 99.97% efficient down to that 0.3 micron diameters. That's what we call our 100s, or our true HEPA filter. And this is what the classes look like. So you've got your not resistance 100s to 95s. You've got your resistance 100s to 95s, and then proofs. Look, there's not a lot of difference in cost, at least before the pandemic hit, between an N100 and an N95. I have no idea why they just don't go with N100s constantly, especially because we've got research that shows, due to poor fit and miswearing, that N95s actually about 20% less effective. N100s are about 20% less effective. So you're not actually getting an efficiency rating of an N95 or an N100. You're getting something that's about 20% less, unfortunately, due to poor fit and improper use. Doesn't always happen that way. But from the research, it shows that, typically you're going to have a reduction in efficiency because of those issues. So the class of the filter is going to be marked on the filter, the package, or the box, and you want to replace them when they're damaged, soiled, it's harder to breathe, right? Or they expire according to the manufacturer. APR cartridges also need to have a tracked service life or be equipped with an end of service life indicator. And if that's not possible, the employer has got to have a change out schedule based on concentration of contaminant. So if not, it's possible to experience breakthrough. So what does breakthrough mean? When we're talking about, a aerosol or a vapor respirator, what does breakthrough mean?
Contaminants getting through the seal?
Yeah. So, you've got, say, carbon, right? Carbon black there from the coconut shells. You got your organic vapor cartridge. You're in a spot with a lot of organic vapors. It's getting used up. Finally, there's not enough spots for those vapors to adhere to, so it starts to pass through the filter into your breathing zone. Maybe you smell it. Maybe you don't. That's why they used to say that you could notice breakthrough by smelling it. That was one of the ways that you could determine changing your respirator. They don't allow that anymore. It's got to be done by an end of service life indicator or a change out schedule. Now, with that said, never ever ignore your senses. So if you've got a respirator on and you don't smell anything and then all of a sudden you do, get out of there. It's time to leave, right? Because something obviously has malfunctioned with that respirator. So service life, basically the time the period of time that a respirator, the filter or the sorbent is going to be able to protect you against what's in the air. These are some examples of end of service life indicators. So basically this one up here, you can see in the top left, there's going to be a black line that develops, right, as it starts to be used up. Here, the one in the middle right, it's going to go and change color. And the one in the lower left, this one here starts to change color from white to orange or red, and then it's used up. So these are different depending upon what the manufacturer is and what the chemical cartridge is. And they don't have one for everything. So you have to be aware of that. OSHA, this is an example of how a change schedule can be tested to make sure that, the employer is indeed doing what they should. So there's some kind of environment that OSHA will introduce into the respirator cartridge, and it's being pulled through by a pump. And then they're going to basically draw a sample to see what the chemical is left over after it goes through the cartridge. So this is a way that they can actually test it. Several factors can affect service life, a worker's exertion level. So the more you're breathing, the adsorbent or the absorbent material inside, that can deteriorate and go bad. Temperature can affect these things, relative humidity, and multiple contaminants, right? So if you've got an environment where you're breathing in multiple contaminants, that can also affect the service life of these things. So with that said, that's all the sciencey stuff on those APRs. What do you think their limits are? What are some limits of air purifying respirators?
Oh, the environment for sure.
Yep.
They're not going to supply you with oxygen if you're in a confined space where there's no fresh air coming in. So yeah.
Yep, exactly. What else?
The filters can get plugged.
Yep, filters can get plugged.
How about how well the person who's wearing it, how well they're disciplined?
Yeah. What do you mean by like do they wear it properly, stuff like that?
Yeah, all the things that go along with responsible use.
Yep. Yep.
Well, it's also exhausting for that person too over time.
Yeah, they're not fun to wear. They are harder to wear than either part of a purifying respirator or supplied air. You're trying to overcome a barrier, right? that's one of the reasons why we need a medical clearance. You're trying to overcome a barrier, and it's not just the barrier of the filters. So normally when we breathe in, we fill the compartment of our mouth up with air, then we fill our throat, and then it gets to our lungs, right? But imagine that cup, right? That face piece that's going to go over your face. You got to fill that up with air first before you fill your mouth up, your throat, and your lungs. So you have to breathe deeper, right? So you got to breathe through filters. You got to breathe deeper to get that air volume into your lungs. So it's an issue, right? It gives you a couple issues to breathe. Before we go any further, Michael M., I have to ask, is that a picture of Hawk's Nest in your background?
It absolutely is. You are one of the very few who have picked that out.
It's a national monument because of the death that happened there.
Yeah, I was going to say it's a tomb.
Yep. Good example of respiratory protection.
Yep.
So for folks who don't know, this was, I don't remember when it was built, but the level of crystalline silica was 100% in a lot of that rock. And people were dying of silicosis in months, not in years, but in months. So yeah, no respiratory protection obviously was used there except for cloth face coverings. Travesty. Good background picture, very, very pertinent to our discussion.
Thank you.
So yeah, no oxygen or deficient, you can't use it in IDLH environments. You've got to know the exposure. So somebody had to have tested what was going on in your work environment to know. And that's a requirement of the standard, by the way. And many employers don't do this. They don't either actually physically test what the contaminant levels are, or they don't do it by historical data. They assume, oh, well, you're gonna be putting this, X coating here on these doors. You've got to be at this level. Well, when's the last time you've seen any painters, actually have their work environment tested for hazardous airborne contaminants?
Virtually never.
Yeah. So how the hell how does the employer get away with that? Well,
Usually if the customer wants it, that's usually when the customer decides, hey, we need to have.
Right. Or an insurance company, right? What do you think the insurance carrier is going to do if an employer has never has anything on the books about air contaminant testing? So it's done two ways. They've either got to do it, by an actual sampling that's done physically by a qualified person, or they've got to do it with due diligence, historical data. So for instance, I know, that a welder operating in the outdoor environment with good airflow with, welding rod MK4 is going to probably have this exposure. They can do it that way, but they've got to prove that they did their work. They just can't make it up. Lower protection factors. The cartridge's service life must be calculated. Not appropriate for rescue. You can use some of these for escape. NIOSH does have some recommendations for that, but all right, don't use an air purifying respirator if the contaminated area's atmosphere is oxygen deficient. If it's an IDLH, the contaminant is above maximum use level or the concentration APR is rated for. Possible unknown contamination exists. The service life is not known. The APR has no end of service life indicator, or there's no program for changing canisters or cartridges. So you've got no way to know when to change these things. So there's a bunch of reasons why you would not want to use an APR. And in fact, the law is backing you up there. Let's see, what are the 3 things you really got to know to choose a respirator? And this is something you want any worker to know. You want them to know this cold.
The environment you're going to be working in.
Okay.
The material you're going to be working with.
Yep. Okay. What else? Yep. It's connected. So the environment is kind of either the oxygen level around which you're working in or the contaminant, right? Then you got to know the amount. So you've got to know what the level is or concentration or exposure is that worker is going to have with that contaminant or those contaminants. You need those 3 things. If not, you've got to go the supplied air. You just cannot simply choose an APR. It's not my opinion, it's the law. Well, actually, I'll back up. It is my opinion, and it's also the law. This is what science says we need to do, all right? Other things to look for is an IDLH atmosphere. If you're using an APR, do they actually make a cartridge for it, right? And is there a governing contaminant standard? So you might have, like I said, the benzene standard, the asbestos standard that tells you what you can use. Let's see. It is 3:20 right now. We're actually, I'm pleased with the time. Why don't we take a 10-minute break? Alice, can we do that? Do we have authority to take a 10-minute break? Get up and stretch, something, do jumping jacks?
We sure can, as long as everybody comes back.
All right. So how about we take a 10-minute break and come back for 3:30? Because I've got 3:20 right now. Does that work? All
Good
right.
deal.
All right. I
Okay.
see thumbs up.
Sounds
So-
good. Back at 3:30.
Yep. You too, Alice. You get a break too.
All right.
All right.
Hey, Bernie.
Hey,
How you doing, man? You
Well-
got some water in front of you? Ice pack?
seltzer, yeah. I gotta put in a window unit in this office.
You do. You have a window in it though, right? That's so the sun's shining in it?
South facing, lucky me.
Is it you got a basement or is that a basement room or like a first floor or?
Second floor.
Oh, okay. So you're just glaring then.
Yeah.
Yeah. Terrible. You need a cold compress and all that other stuff.
Oh, I will be getting one.
Your feet should be in an ice bucket. We would not see it.
That would be a good one. Yeah, I guess you can't tell that I actually don't have any pants on. Just kidding, everybody. See, I have
That's-
shorts. Good God.
That's funny, but that was on the news. Somebody was joking about that the other day, and then and they did that. But it's one of those things that you never know because we're looking at each other from
There was an actual newscaster. I don't know if they were, regular news or doing the weather or something. But the guy had on his, a shirt, sport jacket, tie, and everything, no pants. And the camera was pointing down, so it showed him in his boxers. Oh man. Yep. No
Crazy.
director of photography at home, I guess.
Yep.
All right. Well, it's 3:30. Let's roll. Alice, you with us? I'm not going to start till Alice gets back because something will go wrong. I know it.
Hey, Bernie, call me tomorrow or something like that.
Yeah.
We'll have a conversation.
Well, folks, while we're waiting for Alice to get back, we're doing good on time, so that's good news.
Ken. Hey, Bernie, it's Nicole. I'm here, so even if Alice is a little bit, I don't want to hold up everything, but if you need me, I can pinch hit in a pinch.
Have you just snuck in?
Oh, no, I've been here the whole time.
Oh.
Me
Yeah,
not learning about respiratory protection? Are you kidding me? This is amazing.
All right, what was the answer from slide 14, the third bullet?
Section 3.1, little I, 6.
Exactly.
Thank you.
All right, everybody, we are all back. I take it that everybody got their beers. I mean, seltzers, right? That's what we went to get. Or Cokes, if they're cold enough. All right, let's get moving here. So we've got, some resources for how to select an appropriate respirator. So unless I've done something before and I'm confident on it, I don't just throw respirator, opinions out. I actually go through and I do all this work because no way in hell am I going to suggest somebody go put something on where they're actually not going to be protected, right? We've got to do our due diligence as industrial hygienists. Employers are required to do the same thing here. So my hope is one of the takeaways is that anybody going through this class is going to be able to have an idea if that was done, right? And an employer should be able to prove this, to a worker. They should be able to say, yeah, hey, here is our historical exposure data review, or here's our actual testing. This is what 3M says we should wear for this environment, et cetera. You should be able to come up with that. So first thing is we've got the NIOSH respirator selection logic, and I have, we've given that to you in a PDF. You've got the current version. You can also check if there's a specific chemical hazard standard, like I've referred to before, like the asbestos standard or a benzene standard. You can look in the old pocket guide. Got one of these babies here. They got to change their title though. There's no way in hell this fits in a pocket. I've tried. Although maybe a backpack pocket. Anyway, I digress. So, and then you want to check the assigned protection factor and max use concentrations. And we're going to get into that here in just a second. So first we've got the NIOSH selection logic. So this document is a guidance, and it's what should be used to help determine the appropriate respirator. And it's got 11 steps for selecting which one you should use. So let's go ahead and take a look. I'm just gonna flash this up on the screen. I hope. Hopefully I can do it. Hey, let's see. Can folks see this?
We can see you now, Bernie, but we had you had the front cover of the book showing a minute ago, but it's just you now.
All right, let me see how I can do this. Here we go. How's this?
Here you go.
All right,
You might need to make it a little bit bigger.
bigger. How's that?
That's better.
All right. Look at that, I'm learning Zoom.
Doing great.
Who would have thought? Who would have thought? Now, if I can just beat my kid at some of those Xbox games. All right, so here we got NIOSH respirator selection logic. 2004, it's the current version. I'm going to scroll through. So here we've got our table of contents, and I'm going to get into the third area here. So actually, number 2 and number 3. So the criteria. So for selecting these. Actually, I lied. We're just going to number 2. So this is criteria for selecting respirators, general use conditions. You know, they've got a bunch of requirements here that they want you to look through. And here's the statement. NIOSH recommends that air sampling be conducted to determine exposure levels found in the workplace. So they're suggesting it, but OSHA requires it under subpart I of the PPE section of the OSHA standard. So we've got some, restrictions and requirements for all respirator usage. And I'm not going to go through this stuff, really succinctly. This is something that, especially if you're training on this, on respirators, if you are like a safety representative, or you have any connection to it at your locals or your district councils, you want to get familiar with this. So these are basically just their 11 steps. So step 1 is a respirator intended for use during firefighting, and there's yes, no questions. I've seen some nice flow charts made up of this process. Note to self, I think I'll try my hand at making up one of these on my own so we can use it for the next class. Step 2 is the respirator intended for use in an oxygen deficient atmosphere? And yes or no. Step 3 is the respirator intended for entry into unknown or IDLH atmospheres? Yes or no. And it tells you where to go. And here it's going to break off and send you to a different step if the answer is no. Is the exposure concentration of the contaminants as determined by an acceptable industrial hygiene method less than the NIOSH REL or other applicable exposure limits, like a PEL? And it's going to tell you where to go. So step 5, are conditions such that a worker who is required to wear the respirator escape from the work area, etc.? Yes or no. Step 6, is the contaminant an eye irritant, or can the contaminant cause eye damage at the workplace concentration? So here it's alluding to, do you have to protect your eyes? So you're going to upgrade to a full face. And again, they're all yes or no answers. And then it's going to send you further on down the line. Determine the maximum hazard ratio or max use concentration. We'll look at that. Step 8, is the physical state of the contaminant a particulate, a gas or vapor, or a combination of gas or vapors? So then it fans it out from there. Particulate respirators only, gas or vapor respirators only, or a combination of, and that's step 11. All right, so now we're going to get back to our presentation. All right, does everybody see the selection logic slide again?
Yes.
Okay, all right. All right, what am I gonna do next? World peace? I don't know. We'll see. So that was a quick run through of the selection logic, and you're gonna have an opportunity to use it in our final activity. But again, read through it, and like I said, I'm gonna come up with a flow chart for this, and we'll post that in an appropriate place. Next thing, and I have these listed as 1 through 4, but really I do all of these things. I look at the respirator logic, hazard standard, pocket guide, and then I calculate max use concentrations from either known sampled exposure concentrations or assumed through historical reference. So even though I've got the numbered, you do all of them. So you want to check to see if there's an actual hazard standard. That's going to have its own governance for what respirator you need to use, and that will supersede everything else. NIOSH Pocket Guide, it's going to have respirator recommendations as well based on exposures. So again, if you have one of these, you can look at it. If not, I've got an example up here for gasoline. So it's going to have a section here in the pocket guide for every contaminant that's got listed, all 677 of them. I think that's what they got in there. Respirator recommendations. You also might have to go to one of the tables in the back. So here we've got recommendations from NIOSH. This is SCBA-F. I love these acronyms. I love it. Let's see, self-contained breathing apparatus, full face piece. Pressure, demand, positive pressure, supplied air face piece, pressure, demand, positive pressure, escape, SCBA. I think that's what that means. So you want to go up, and again, all those codes, they're located in the beginning of the book. They are a pain to remember, but once you get used to them, you can rattle them off. If you're ever on Jeopardy and it's a question, you can thank me later because you'll get it, right? But nonetheless, you check the NIOSH Pocket Guide to see if your chemical's in there and if they give you a recommendation. This bottom one is for escape only, gas mask, full face, organic vapor / SCBA escape. Assigned protection factors. So this is going to be important to use for determining maximum use concentrations. So, this was part of the OSHA standard. You probably ran into this when you were looking up one of the questions. So we've got different assigned protection factors. So what this is, it's the concentration outside of the mask compared to the concentration that was able to sneak in to inside the mask. So the higher APF, the better, right? So we see our air purifying respirators, a full face piece gets a 50. A powered air purifying respirator, full face piece gets a 1,000, but helmet and hoods, they've got different levels. And of course, the best one is 10,000 with your pressure, demand, positive pressure, SCBA. Some things that are going to actually, reduce the values of those APFs, we talked about them already. Face shape, size, scarring, improper fit testing, improper use. SCBA, SAR may not provide positive pressure during a peak respiration. So in other words, you're breathing heavier than what the system can keep up with. That could be the case, I hope not. But also heat and cold can affect these things as well. All right, now let's look at max use concentration. So it's a simple calculation. So what you're going to do, and the maximum use means you cannot exceed this concentration. There are some lower concentrations that would be more important. Well, we'll get into that in a minute. But what you do is you take the assigned protection factor and you multiply that by the chemical's 8-hour OSHA PEL. So let's try one. So we've got a full face APR, quantitatively fit tested, and we'll be working with xylene. So what is your max use concentration? So let's try that out. So if you've got your pocket guide handy, look up for xylene. And you can take any form of xylene. There are 3 xylene forms based on the position of the methyl groups. You can take any one. It's all got the same PEL. So you look that up, and if somebody comes up with the TWA for OSHA, let me know what that is.
100 parts per million.
Yep, 100 parts per million, good. So we take our 50 APF, we multiply it by 100 parts per million, and we get a max use concentration of 5,000 ppm. So technically, this allows us to use that respirator in that chemical environment up to 5,000 ppm, but there's always a but with respirators. The IDLH is 900, so we must only use it up to 899 ppm in accordance with the NIOSH selection guidance. And I would also want to check what it says that I can do here. And yep, so underneath the NIOSH respirator recommendations, it says 900 ppm organic vapor up to that amount, because that's what the limiting factor is. It's your IDLH concentration. So you can see there's a bunch of steps here. So, you know, an employer would have had to really done some good due diligence to put together a respirator program, figure out what you are exposed to before they hand you that respirator, right? Who certifies respirators? NIOSH, that is right. Used to be MSHA as well, the Mine Safety and Health Agency, but no longer. It's only NIOSH certifies respirators. So you should find a NIOSH label on your respirator or with the accompanying material in the packet or stamped on there somewhere. All right, good. So we just covered a lot of, you know, the science, the mechanics of respirators. Are we ready to throw one on and get out there? What do you think? A student just went through all that. No? I see people shaking their heads no. What else do you have to do?
Medical eval?
Yeah, I got to do a medical eval. Like I said, again, another reason why I did not like doing consulting for private industry folks is I was asked to come down and do some fit testing for some APRs for a group of folks. And I said, okay, well, please provide me your medical clearance certificates by a qualified, you know, provider. Oh, I'll give those to you when you get down there. All right, sure, fine. I get down there. First off, I said, you know, can I see the training certificates? Well, what do you mean training certificates? I said, well, you know, all the workers have to have training on the respirator standard and respiratory protection before they put them on. Well, they never did that. So luckily, I just happened to have my laptop and stuff in my car. So guess what? I'm going to be here longer. So we did a respirator course, which was something like this one. It was a little truncated. And then I said, all right, so where are those medical eval certificates that I can see? Turns out they never got them. And I said, look, you know, I'm sorry, but I can't fit test anybody. Well, why not? You're only going to be putting them in respirators for 10 minutes. I said, yeah, it's 10 minutes to a heart attack. I said, I can't do that. And I said, and by the way, it's not my opinion. So I broke out the standard, and there it said in black and white, you cannot put a worker in a respirator for any reason until they are medically cleared, for obvious reasons, right? So it's important. It's important to protect that worker's well-being before they put one on, that they're okay to wear it. What else do they have to do? So we mentioned training and we mentioned medical clearance. Anything else?
Fit test, right?
Yeah, fit test. That's right. Yep. Fit testing, donning and doffing. So do they know the right procedure for putting one of these on and taking it off, right? And other training. So medical screening, medical evaluation, there's a bunch of ways that you can name this, but it all means the same thing. Basically, they start with a medical questionnaire that is given by an approved medical provider, occupational nurse, you know, a clinic, a doc, something like that. And then they look for some flags. So if you've got asthma, like, you know, like me, red flag, I'd have to go get a further evaluation. If you smoke, had trouble breathing, you know, heart condition, et cetera, you'd have to go and get more evaluation. It doesn't mean that I can't put it on with my asthma. It just means that I got to go and make sure I'm good to go, right? And thank you, law, for that, because I want to know that I'm good to go when I put one of these on. The last thing I see in my life, I don't want it to be a respirator face piece. So we got to make sure that you're okay to go. If you are, then we can do fit testing. So it's going to be performed with a negative or positive pressure, tight fitting face piece, different face pieces from the one that you're fit for. You have to make sure that you're getting a fit check with what you will be wearing. It's very important, and it's the requirements of the law. Fit testing must be done annually, and if facial structure changes, you got to have it rechecked. Also, if what you've been using, you don't think it's working, maybe you're experiencing breakthrough, maybe you're having discomfort for whatever reason, you might need to get refitted. And again, you know, a fit test, there's going to be a prescribed method that OSHA requires to go through it. It doesn't mean it's foolproof. It's technically, it's in a lab, right? It's in a condition that's not work. So if you find that it's not working for you in work, you got to go back and get reevaluated, maybe a different respirator, different model, etc. Proper donning and doffing will ensure that the efficiency and is there, and that it's going to reduce possible contamination into your lungs. So very important, right? So it's very important that whoever is handing out this respirator and giving the training, that you're actually getting training on the respirator you're going to use. So that is part of that work required one. So even though folks have gone through this, the employer still has an obligation to do training that meets their work environment. So the hazards that they're going to face, they have to be communicated to the workers, and you've got to get training specifically on the respirators that you will be using. With that said, if we are in a hands-on class, a face-to-face class, we would all do this together. But thanks to Ken, we've got the next best thing being thousands of miles apart. We got a little video we're going to watch here. It's about, I think, 10 minutes or so about properly putting on and taking off, or donning and doffing, if you will, a respirator. So let's check this out.
Brothers and sisters, we're going to go over donning and doffing of a half-face elastomeric respirator. Before wearing any respirator, before using any respirator, you need to make sure that you fully read, that you fully understand all the manufacturer's instructions. Now for our US brothers and sisters, you need to make sure that you understand and follow all the rules and regulations of Occupational Safety and Health Administration, OSHA. And for our Canadian brothers and sisters, you need to make sure that you understand and that you are following all the rules and regulations of the Canadian Center for Occupational Health and Safety. Now, all of our district council training centers have a respiratory training program. You need to make sure that you attend one of those programs prior to wearing a respirator. During that program, you will understand the use and limitations of the respirator that's being issued to you. In fact, you'll understand if you're capable of wearing a respirator prior to one being issued to you. So prior to wearing a respirator, make sure that you go down to your district council training centers and you attend one of the respiratory training programs. Now today, we're going to go over the donning and doffing of my 3M 7300 series half-face elastomeric respirator. I cleaned it yesterday prior to storing it, but you might ask, why is he having it in a paper bag? Well, you want to store your respirator in any container that's clean, a lot of times in the field, you might see a Ziploc baggie being used. If a Ziploc baggie is what you use, make sure that you don't zip it all the way up. Make sure that you stick some type of an absorbent pad on the inside. So if the baggie does start accumulating moisture, the absorbent pad, like a paper towel, can help eliminate that. Now, my 3M 7300 series half-face elastomeric respirator was cleaned, like I said, the night before. So when I take it out of my storage, I'm going to look at it and make sure that it's in good working order. I'm going to check the head strap. I'm going to check the head the head straps and make sure that they're in good working order. I'm going to check the neck straps and make sure that they're in good working order. I'm going to look at the body of the respirator itself, make sure that there's no cuts or tears. I'm going to make sure that the respirator is not distorted and it's in good working order. I'm going to look at the inside of my respirator and I'm going to check my inhalation valves and my exhalation valves and make sure that they're laying flat and that they're sealed and they're in good working order. I'm going to make sure that, again, that my respirator is clean. And as long as I know that my respirator is in good working order, then I can start donning the respirator. But if the respirator did have a defect, then I need to make sure that I report that to the proper person. And employers are supposed to have a respiratory program that you all have to follow. Within that program, there should be a person that you go to if there's an issue with your respirator. Now, if it's a part that can be replaced, it can be replaced. But if it's a defective respirator, a respirator that's torn or can't be used or distorted and can't be used, then it needs to be replaced. Do not, I repeat, do not wear a defective respirator. This respirator is protecting you from something that is harmful to you. So make sure that your respirator itself is in good working order. Do not use a defective respirator. Now, I store my cartridges separate from my respirator. This is not a cartridge training program. This is donning and doffing of a respirator. So let me put my cartridges on prior to donning it so we can do a proper seal check with the cartridges on. My cartridges are locked in. So the first thing I'm going to do on donning and doffing this respirator is I'm going to bend over slightly. I'm going to put it over my nose, mouth, and chin. And I'm going to take the head strap. I'm going to put it on the crown of my head so it cradles it. Then I'm going to take the neck straps. I'm going to put it around my neck. Lock those in below my ears. And then I'm going to adjust the straps. I don't want to adjust it so the respirator is too tight. I want to adjust it just enough so the respirator is snug but not tight. So I've adjusted my straps. My respirator seems to be fitting good, but now I have to do what they call a seal check. And to do a proper seal check, I'm going to first do a positive seal check. And what I'm going to do is place my hand over the exhalation valve. And I'm going to blow out slightly. And you'll see my respirator kind of go away from my face. I don't want to blow too hard so it pushes completely away from my face. I just want to blow enough to see if it's leaking through the seal of the respirator. I don't feel any air leaking from my face or the seal of the respirator, so positively, I got a good seal check. Now I want to do what they call a negative seal check. I'm going to place my hand over the cartridges, and I'm going to breathe in just a little bit, and you'll notice my respirator suck in. And that means I don't have any air coming in from the seal of the respirator. So now I know that I got a properly fitting, seal-checked respirator. I'm ready to go to work. Now, I'm done with work. I need to doff my respirator. Now, to properly doff my respirator, depending on the circumstances I'm in, if I'm in a really dusty area, one that's got a lot of dust, I might have dust sitting on the bridge of my respirator. I want to make sure I kind of wipe that excess off a little bit. I don't want it to follow my respirator and go into my breathing zone. So what I'm going to do is I'm going to actually hold my respirator. I'm going to take my straps in the back. I'm going to disconnect my straps. I'm still holding the respirator to my face. And I'm going to take the head strap off my head. And what I'm going to do is I'm going to take a little breath, move the respirator from my face and point it downwards. Away from my face and pointed downwards. So that way, if there's anything that accumulated on the respirator, it's falling away from my breathing zone. Thank you. How was that?
All right, that was a great video. And in lieu of me trying to explain that all to you and put everybody to sleep, that's really the best way to do it at a distance learning like this. So that was a very good video. The only kind of hang up that you might have, it happens to me sometimes, is when I go to do the negative, seal check. I can't get a good cover on the cartridges, so I'll just take a couple plastic bags, put them over, and that helps me cover it enough so that I can get that negative pressure on my face. So, but that's the way you want to do it, and it's got to be done like that every time. Look, the IUPAT members, there's a lot of chemicals that everybody uses. I mean, it's the work you do, right? So, engineering controls have to be first and foremost, but you're going to have to rely on many cases on a respirator. So we want to make sure that folks have the right one, that they fitted properly for it, they can wear it safely and medically, and that they know how to put it on and take it off the right way. So, all right. So taking care of your stuff, right? This obviously is not a good method for taking care of your respirators. It's amazing what you find when you do inspections. So cleaning, basically you want to clean your respirator in accordance with a manufacturer's recommendation, but it's something that you're going to want to do before you put it back in a bag. You don't want to be putting it in a bag when it's all filthy and dirty and potentially be able to contaminate the inside of the face seal. And the manufacturer is going to have the way to do that. And you want to do it properly. I remember when I used to work at UMass Lowell at a training program there, right out of graduate school, we went through so many respirators for classes all the time. So we had a HAZWOPER training program. And the equipment tech just ran them through a dishwasher. It wasn't the right way to do it. But every now and then we'd find melted seals. So people actually couldn't breathe in on the respirators because the seals were melted. So then he had to start checking them all. So dishwasher, not the right way to do it. So you want to make sure you're doing it in accordance with the manufacturer. We're just going to watch a video here. This is nice because I've actually never seen a training video on care and maintenance and stuff like that. So this was nice. So again, in lieu of being here together in the same room, we're going to watch Brother Ken get into it.
Brothers and sisters, today we're going to go over the proper way of cleaning, disinfecting, and rinsing a half-face elastomeric respirator. Prior to getting started, the respirator that was issued to you, you need to make sure that you've read and that you understand the manufacturer's instructions. For our U.S. brothers and sisters, you need to make sure that you understand the rules and regulations of Occupational Safety and Health Administration, OSHA. For our Canadian brothers and sisters, make sure that you understand the rules and regulations of Canadian Center for Occupational Health and Safety. Now, the setup I got here, I have a wash station, I have a disinfectant station, I have a rinse station. But within the regulations, the Canadian, the US, and the manufacturer instructions, there's a little bit of discrepancy. But the Canadian regulations and the OSHA regulations, those do state to follow the manufacturer's instructions. Manufacturer's instruction says the water not over 120 degrees. The US standard, federal standard says not over 110 degrees. The Canadian standard says not over 120 to 140 degrees. So we're going to keep the water somewhere right around 110 degrees on all of my stations. I'm going to check that by a non-contact thermometer. And right now my water is about 110 degrees. Now, on the cleaning solution, you can use a mild detergent which I'm using. You can use a manufacturer's solution. You can use other solutions out there that's designed and manufactured for a respirator. But you don't want to use anything that contains lanolin or oils. Today I'm using a mild detergent. But my mild detergent doesn't have a disinfectant in it. I do have to disinfect my respirator. So I'm going to make a disinfectant. I'm going to make hypochlorite. The way I'm going to do that is I'm going to use 1 milliliter of laundry bleach to 1 liter of water. Stir that up. We have a disinfectant. Now I got my rinse bucket. Don't overestimate or underestimate your rinse. This rinse is just as important as the disinfectant and as the wash. If you do not disinfect your respirator in the proper way, you can get dermatitis and other issues. So make sure that you clean and rinse the respirator in the proper way. We've checked our water. Our water's at good cleaning temperature. Now, if I was in the field and I was using my respirator, in between uses, I could use a cleaning wipe. I could use a manufacturer's cleaning wipe, or I could use some other type of respirator cleaning wipe in the field. But it cannot be the only thing that I use. My respirator must be cleaned daily. In fact, the Occupational Safety and Health Administration OSHA regulation says mandatory. Canadian says follow manufacturer's instructions. Manufacturer's instructions says clean daily. So you need to clean your respirator thoroughly on a daily basis. And to do that, you need to take your respirator apart. Now we're using my 3M 7300 series half-face elastomeric respirator. And the way that I'm going to do that is I'm going to take the front part of my respirator and I'm going to take it away from the body or the face piece of my respirator. I'm going to lay it out. And then I'm going to take the exhalation valve. And the way this works is when I breathe out of the respirator, this flap goes up and lets the air out. When I breathe in, it seals and the air goes through the cartridges. So when I breathe out, I'll show you those in a second. The diaphragm seals and forces the air back out. So I'm going to take out the exhalation valve. By this point, it's got these tabs in there that hold it in. So I'm going to pull those out. Then I'm going to take my inhalation valves. And I want to make sure they're not destroyed. They're round. They can be replaced. They got replaceable ones out there. I'm going to pull both of those out of there. Now I'm left with the body of my respirator. I'm going to take my cleaning solution and put my respirator in there, and I'm going to use a bottle brush. I find a bottle brush works very well, and it's soft bristles because I don't want to distort the respirator. I don't want to scrub it so hard that I start tearing it or distorting it in any way. I find that a bottle brush works very well at cleaning the respirator. So I want to make sure that I get in all the crevices all around the respirator, in every part of the respirator, and make sure that it's thoroughly cleaned. Make sure it's thoroughly cleaned. That is good. And then I'm going to put it into my disinfectant. And my disinfectant solution, which I told you was hypochlorite, I'm going to let it soak for approximately 2 minutes. So as that's soaking, I'm going to take the front piece of my respirator with the head strap and the neck straps, and I'm going to clean that using my bottle brush. Again, I find that a bottle brush works very well. So after that's clean, I'm going to let it soak for a couple of minutes. Now, the body of my respirator soak for this 2 minutes. So what I'm going to do is make sure that I rinse it off very, very, very well. Now, running water going down a sink is preferred. Because that way they disinfect it and so it doesn't start building up in your rinse water. If you use a rinse water, make sure that, and you use it in a bucket scenario, make sure that you're changing your rinse water often. Again, very important step. You don't want to miss it, and you want to make sure that you thoroughly rinse everything off the respirator. Then you either want to hand dry your respirator if you're going to use it, but you want to use a lint-free rag, and you don't want to scrub on it. You just kind of want to pat it dry, and that way you're not distorting the face piece of the respirator itself. But I like to let mine air dry. So I'm going to take my piece as I was rinsing that off, my front part of my respirator, and I want to rinse it. Make sure it's thoroughly rinsed. And I like to go step by step, piece by piece. That way I don't lose track of what I'm doing, because it's very important that you get your respirator thoroughly clean. So I'm going to let that air dry. Now I got my exhalation valves to clean. I'm going to make sure that I place that in there. I'm going to hold it in my hand. I'm going to take my bottle brush. I'm going to clean both sides of my exhalation valve. I'm going to stick it in my disinfectant for approximately 2 minutes. And as you notice, I'm wearing gloves, right? It's very important that when you're cleaning your respirator that you're wearing gloves. Using a disinfectant, using dish detergent, and it can be bad for your hands. So I got gloves on. It's a very good precautionary measure. I'm washing my exhalation valve. I'm going to rinse it, make sure it's thoroughly rinsed, and let it air dry. Take my diaphragms, again, making sure that they're not distorted, they're perfectly round, and I'm going to wash those. Place that one in the disinfectant. I don't like to do the other valves and stuff together because you kind of lose track of them when they're in there. But I have two of the same valves, good shape. I'm gonna wash this one, stick it in the rinse water or the disinfectant water, and make sure that this one is good again. I'm gonna stick it in the rinse water and make sure that it's thoroughly rinsed, completely rinsed. All the disinfectant, all the cleaning solution is off the diaphragm. Take my other diaphragm out of the disinfectant water. Make sure that I rinse it thoroughly. And let that air dry. Again, I can use a lint-free rag and dry the respirator. But I like to clean mine on a daily basis. Now, it depends on what your respirator was used for. Sometimes we might have to, by a respiratory program that a contractor is supposed to have, is leave our respirator at work. But we still have to clean them on a daily basis. So at work would be a cleaning station and a disinfectant station, so you can clean and disinfect the respirator at the end of the shift. But if you bring a respirator home, then you can have a cleaning station set up at your house. If what you were dealing with wasn't too hazardous, you can use a sink. This is the way I like to do it. But there's other options, there's other avenues, there's other ways that you can clean and disinfect your respirator. Thank you. What do you think?
All right, nice. Thank you, Virtual Ken. All right, so
I gave it a stab, Bernie, but thanks for putting that in there. Hopefully everybody found it rewarding.
no thanks needed. We needed it in there because you don't want to watch me do that here in my hot office. So, what I like to do is I like to get students actually taking, a respirator apart so that they're not, nervous about it, afraid they're going to break, et cetera. It's designed to be taken apart. And like Ed said, they got to be, cleaned every day. The manufacturer's recommendation stated in there. How many folks here have been on a job site where the employer has made that known? That's required that you clean your respirator every day after the work. But it says right there in the standard, you got to clean in accordance with manufacturer's instructions, and that's every day. So it's really important, you know, if stuff builds up on that, you know, it's a pathway for contamination into your lungs, into your breathing zone if it's not done appropriately. So after you do it, it's got to be, you know, packed and stored in a way that's not going to, you know, degrade the respirator, that's going to protect it. You know, if you are in places that Ken lives, where it's, what is it, 108 degrees today out in the desert?
109.
109, 108, 109. It's all hot. Imagine what's going to happen to that, you know, silicone seal, right? If it's just left up in the back seat of your car or truck where the sun's beating down through the glass. It's going to deteriorate it quickly. It's going to become brittle, things like that. So you want to store it properly. You got to make sure that you inspect it, you know, before you put it on. Before use, during cleaning, you know, if it's an emergency response respirator, it's required to be inspected monthly. And for each use, and then an escape bottle before you enter somewhere. And again, you know, as this states down here, all this stuff's got to be, you know, part of a respiratory protection program that the employer has. Maintenance is going to go in accordance with manufacturer's recommendations. Don't modify respirators. OSHA training. So, you know, you got to receive some additional stuff from an employer, which is specific to their program, to that work site, to those contaminants that they're going to be exposed to, and what the respirator is that they are going to use. What if my employer tells me I don't need to use one, but I think that I do or I want to? So you can go through the voluntary use respirator Appendix D requirements. The employer still has to do some stuff, make sure that it's not going to be a detriment to you wearing it. And there's some other provisions in that Appendix D that has to be followed. You know, basically, you know, it's allowed, but they just have to make sure that it's not going to become a hazard to you as a volunteer user. Also, you know, understanding your coworkers while wearing a respirator can be difficult. It was actually pretty clear to hear Ken during that video when he was putting it on. But it's not always the case. Sometimes people have difficulty hearing each other with these. You know, issues of lenses fogging up. Typically that's an issue of fit, right? You don't have a good nose piece over there, so there's moisture getting out. Claustrophobia, glasses, and again, communication devices. All right, so we're gonna do activity 2 now. Jeez, I'm allergic to myself from my office.
Bless you.
So this is activity 2. We've got 10 questions here. So Alice is going to put everybody into groups again. So you want to split these up and use all the resources that you've got at your disposal to answer these questions and some of the scenarios there. And I think we're going to give you all 12 minutes this time. So with that said, take it away, Alice.
Okay, so yep, 12 minutes. Once you get the notification that you'll have 60 seconds to wrap up what you're doing. So 13 minutes all together. And don't forget to click on join when you are prompted to do that. Okay, here we go.
Hey, Alice. How are you doing?
Good. Boy, 95 in your office, that's crazy.
Ridiculous.
Well, the house I live in is, you know, pretty big, built in 1926. And when we moved in, it's been over 20 years. That was the first thing we did is put central air conditioning in.
Oh, man.
Because my husband grew up in Long Island. I grew up here in Baltimore. Neither of us ever had air conditioning.
Yep. Yeah, I grew up with just this metal window fan that my parents would put in my in my bedroom.
Oh, well, that was better than what we had. So we had a attic, and they put one big fan in the attic, and you had to open your bedroom window on the floor below, like an inch or two at the most, to pull the hot air through.
Yep. Now that I have AC, I can't ugh.
Yeah. And it's hot.
Yeah. What's our time here?
So 4:24, we have about 5.5 minutes.
All right. Not for nothing. I'm gonna go stand in front of the air conditioner again.
Okay. And so we're going to debrief this, and then you'll be finished or close to finished?
That's it. I mean, I think this activity is the very last slide, except for comments or questions.
Okay. All right. Well, so then ask for questions. I will put a reminder in the chat that they need to go and fill out the training survey. So if you want to plug that as well.
Okay.
That way they can get a course completion.
Yeah, I wanted to to ask if there's because I'm always used to doing trainings with eval forms or something. So okay.
Yeah. So there's an e-learning. There's a survey in the course code, and I'll post that in the chat.
Okay, perfect.
Yeah.
All right, I will be back in 3 minutes.
Okay, sounds good.
All right. All right.
All right, we're less than 2 minutes.
I was gonna go have an ice cream bar after this, but I think I'm just gonna jump in the freezer. We have a small floor freezer in the basement for extra food, so I think I might fit.
Oh, you might. Keep your feet in an ice bucket. That'll cool you off.
Yeah. Because it was, you know, we were all bummed out that we couldn't make our Disney trip this year. So what we've been doing is buying Mickey bars and Mickey ice cream bars and Star Wars bars. So
Oh my gosh.
we've been having like 2 a day for a month, I think.
Oh my gosh. When were you supposed to go?
We were going to go to Disney for, I think, 7 days at Animal Kingdom Lodge, and then Universal Studios for 3 days.
Oh, nice.
Yeah. It's our go-to. We have annual passes to Universal Studios. We go down usually when we get good flights, but at least once a year, sometimes twice. All right.
All right, 16 seconds, and then there's like 30 seconds to wrap up. So they'll be back in a minute.
Shot another one of my shades. Ugh, those windows are hot. Here we are. All right, we got everybody back? Is that everybody, Alice?
No, not yet.
Okay.
25 seconds, and they'll have to be back. Okay, everybody's back.
Everybody's back?
Yep.
All right, so some of these were a little tricky on purpose. Some were a little more straightforward. So I'm just gonna go read through these, and somebody wants to give an answer. What is the protection factor for an SCBA? This is question 1.
10,000.
10,000, good. You will be mixing USG Easy Sand joint compound throughout the week as needed. Do you need to use a respirator? If so, which one?
Yes, and a NIOSH approved one.
Yep. And what level or what grade respirator would you suggest?
Personally, I would use a half face with the magenta filters.
Yep, that's probably what I would go with, you know, N95, depending upon, you know, the dust cloud. But did anything, let me be clear though, I would much prefer an elastomeric half face with, you know, with the HEPA cartridges.
That's right here. This one's right here.
What's that? What particularly jumped out about using that Easy Sand material?
Silica.
Yeah, silica, right, good. And you got to be careful too, because sometimes, you know, some of these labels and stuff, they're tricky. Like they might, I've seen silica called natural sand. I've seen asbestos called mineral fibers. You know, so you got to be careful. All right, good. Number 3, the airborne concentration of methyl chloride or methylene chloride is 97 ppm. Oxygen levels are normal. The health and safety plan requires a full face APR with organic vapor cartridge. Do you think this is adequate protection? Why or why not?
No, sir, because the pocket guide says you need an SCBA.
Yes. And specifically, it has a standard all of its own. And in that respirator section of the pocket guide, it refers you to the back of the book. And under the OSHA specific standard, it requires supplied air respirator or SCBA full face. Very good.
Yeah. No, thank you.
Very good. All right, number 4, you're about to clean up a toluene spill that's not an emergency. So in other words, it's not out of control, it's a spill. The concentration of toluene is 800 ppm. Oxygen levels are normal. Your supervisor hands you a half-face APR with organic vapor cartridges. What's your response?
No, thanks.
No thanks. How come?
Because in the pocket guide, you should be wearing an SCBA.
Okay.
Isn't it IDLH 500 or IDLH is 500?
Yes. Yes. So the PEL is 200, right? If you're wearing that half-face APR, you got a protection factor of 50, so that's higher than 800, but the IDLH is only 500, so you're limited there. So yes, you cannot use that. It's IDLH. You need supplied air, preferably full face, positive pressure SCBA. All right, you are working in an atmosphere containing 300 ppm of carbon monoxide. If oxygen levels are normal, what type of respirator can you use?
Supplied air or SCBA is what NIOSH recommends, only supplied air when working around carbon monoxide.
Yep. So PEL is 50, the IDLH is 1200, but because of its unique characteristics, supplied air up to 350. So that could just be an airline, half face airline, loose hood, whatever. After you get above 350, you got to go to positive pressure, full face piece, supplied air. Good, very good.
We were, question on that, Bernie, is when we were looking at that, maybe we misunderstood it. We were looking at the NIOSH, so it said 350 parts per million.
Yep.
Normal oxygen, it's a cleanup. Would you need supplied air, or is because it's below, because it said it's only 300, we thought just a regular half face would be okay, but we might have misunderstood.
Yeah, so the way this works, and it's confusing. It took me years of going back. I'm going to read it here so I don't mess it up. So I'm on page, oh boy, Roman numerals 15. It's XI in the pocket guide. At the very bottom paragraph, each subsequent line lists a maximum use concentration followed by the classes of respirators that are acceptable for use up to the MUC. Codes for various categories of respirators and assigned protection factors for these respirators are listed in the table 3. So basically what happens is you're going to use what they suggest up to that number. So up to 350, you need to use supplied air.
That makes a lot more sense.
Yep.
All right.
And then after 350, you've got to defer to, so between 350 and 875, you can use a supplied air with a CF, which is a,
okay.
Forgot.
We thought at 350 you needed supplied air. Okay.
Yeah.
Continuous flow.
So up to 350, you can use supplied air, but you need supplied air.
Okay.
If it's above, it's, let's see here.
Continuous flow, is that what it is?
Yeah, continuous flow, thank you.
Okay, see,
See, after 25 years, I haven't remembered all these damn acronyms.
There's a few in there.
Yeah, a few of them. So, and what you can do is, you can use any higher respirator for any lower level of exposure. So you could use that supplied air continuous flow for 875, 700, 350, 200, whatever, right? So you can always use it for lower exposure levels, but you have to upgrade if you're going higher. Good. You have xylene vapor and lead dust on a site, and you have determined that concentrations are low enough to use a full face air purifying respirator. What type of cartridge should you use?
And a CCRFO V100.
Yep. So you're using a combination cartridge, organic vapor and a HEPA cartridge. Good. Which organization certifies respirators?
NIOSH.
Good. You are using an oil-based paint to coat dozens of steel doors, jambs, and casings in a large complex of storage unit buildings. The HVAC system, which only feeds conditioned units and the lobby and offices, is not operational yet. The temperature in the building is 95 to 100 degrees Fahrenheit. Oh, just like my office. Is respiratory protection required? And if so, what would you select and why? Do you have any other concerns? What'd you pick here?
We said you need to do some air monitoring,
Good.
determine what the values were, then you can choose a respirator, and you'd also have to consider the upper explosive limit and the lower explosive limit.
Very nice. This was one of my ringers. I threw this one in there. So with that,
How'd Group 5 do?
What's that?
How'd Group 5 do?
I don't know who Group 5 is.
That's me and the guys I was in.
Oh, there you go. You did great.
All right,
So
nice.
that's a hard one to tell unless you do some monitoring, right? Because you've got a higher temperature. You're going to be pushing off more vapor into the atmosphere faster. You're basically in an enclosed space. It's not a confined space, but it's enclosed. You don't have air exchange. I wouldn't choose anything until I've monitored for it. I'd put everybody in supplied air until I monitor and then downgrade if appropriate. Good. What does the North American Emergency Response Guidebook, and I apologize, we didn't put one of these in PDF, state is the respirator of choice for responding to a sulfamic acid spill?
SCBA.
Yep. And this is kind of a funny question because every respirator in there is SCBA because it's Emergency Response Guidebook for first responders, right? Last one, describe the general process of what needs to occur before any respirator is considered. What do you do? What do you want to do?
Environmental conditions, products being used.
Yep.
Air samples.
Good. So you want to determine, oxygen level, the chemical you're using, exposure level, right? So what's the concentration? Any unique work circumstances like we had there from question 8. And then what are those 4 resources you will check once you have all that information? Remember those 4 resources we went through? One was the pocket guide. What other 4 things would you use?
NA, ERG.
You could, but that's not one of the main resources that we looked at for selecting your respirator. One was the NIOSH decision logic, right? That greenish color book. If there is a hazard standard, like for methylene chloride, benzene, asbestos, cadmium. And then lastly, you want to calculate the max use concentration. And with all 4 of those things, you apply that to the data that you've got from your exposure assessment, your work assessment, and then that'll help you choose. And that is number 10. Any comments or questions? Anything left over from that activity? All right, this is it. Now, if we're face-to-face, we throw on some respirators and have a good time, but we're not. So we're just going to end the class and have a good time. So any comments or questions? Anything that I've left unanswered? Anything that might have brought up another question? No?
Well done for a Zoom,
All right, yeah.
What we got.
Right. Remind the owner of this office to get me an air conditioner, will you? So Alice might have some closing statements about where to go for a survey or a certificate and things like that.
She's posted it in the chat already.
Oh, man, she's good. Nice.
You were watching, yes. So I just posted a reminder in the chat to go to the course, FTI 175, to complete the course survey, and you'll get credit on your transcript for attending today.
All right. Well, thanks everybody for coming on board and sitting through this. Hopefully it was of use to some folks. And with that, I think we've concluded respirators.
Thanks, you
Thank you,
guys.
Bernie.
Thank you,
Well,
Bernie.
thank you,
Thanks for your time.
everybody, and thank you, Alice and Nicole, and anybody else from the IFTI staff that helped me make this a success, I guess. We didn't crash. We didn't crash and burn. No computers lit on fire.
Nope, you almost did.
Thank you.
I almost did. I'm gonna go jump in the freezer.
Thanks, Bernie. Well done.
All right, bye, everybody.
Yeah,
Thank
bye.
you.
Bye.